infinite geometric series. So an infinite geometric series is exactly what it sounds like. So geometric series that goes on forever. Now we have two types of these. We have one where our common ratio is bigger than 1, and that means our numbers just get bigger and bigger and bigger, or smaller and smaller and smaller, and we can't find the sum of them because it's just infinity or negative infinity. We call those ones divergent. So they either get too big or too small, we actually can't find it. And then we have the ones where r is less than 1. In that case, r gets really close to 0. Eventually it gets smaller and smaller, you get 0. And you actually could find the sum of those. We call those convergent. So those are the ones we're looking for. So anytime r is less than 1, we actually could find the sum of that infinite series. And that's what we're going to be searching for. Now the formula to do that is this right here. It's a super simple formula. It's the sum of an infinite series, I'll use a little infinity sign below, is the first term over 1 minus the common ratio. Now this only works when the absolute value r is less than 1. Why is the absolute value? I don't care if it's a positive or negative graph. It doesn't matter to me. As long as a ratio. As long as it's less than 1, that means it's getting smaller and we can do it. So the first question here. Write 0.7 the line over as a rational number. Now this is kind of tricky. The general idea here is this. 0.7 with the line over is this guy, right? Is just this. So if we look at that a different way, let's look at this one first, right? That is 0.7 is 0.7 is, just by that one stuff, is 7 over 10. Right? And how about this one right here? Well, that is 7 over 100 because it's 100 terms. And this one right here will be 7 over 1,000. And so on. So how do we find the infinite sum of this? Well, what is our ratio? What's going on here? What are you multiplying by each time? Our ratio, remember I talked about to find the ratio? Ratio is always the second term over the first term. If you notice what's happening here, we're multiplying by 1 over 10 every single time. So our ratio is 1 over 10. That is less than 1, so it is convergent. I could find it. And what is the only thing I need to find my formula here is u1 over 1 minus r. I have the r, right? Only other thing I need is my first term. My first term right here would be 7 over 10. So that's how you're supposed to see infinite numbers, right? 0.7 is just 0.7 all the way through. That right there is 7 over 10. Next one would be 7 over 100, 7 over 1,000, yada, yada, yada. Right? If I want to find the infinite sum, your ratio has to be less than 1. Well, look what's going on. All we're doing is multiplying by 1 over 10. That's less than 1. So we can't find the infinite sum. And then our first term is 7 over 10. So substitute it in. I'm running out of space here. So I get 7 over 10 over 1 minus 1 over 10. You can put that in your calculator if you're scared, if you don't want to do that. But really all this is this. The bottom here is 10 over 10. So 9 over 10. The top here is 7 over 10. This is just a divide sign. So we have 7 over 10. That's an ugly 7 over 10. Times the reciprocal of the denominator here. So multiply by the reciprocal. So 10 over 9. These cancel out and you get 7 over 9. So that's how you do it. By the way, if you want a little bonus math content, that's how repeating numbers work. If I gave you 0.3, that's the same thing as 3 over 9, which is 1/3. 0.5, oh, I meant 0.3 repeating, sorry. 0.5 repeating would be 5 over 9. Right? That's how the repeating numbers work on the tenths place. You just put over 9. Which, by the way, interesting note, what happens if you have 0.9 repeating right here? Well, that would be 9 over 9. Is that just 1? Yes. 0.9 repeating is the same thing as saying 1. Those are equal. Next one. They want us to find the infinite sum of this thing here. Now, look at this. Does that look familiar? It's a geometric sequence. Remember in geosequence? It is un equals u1 times r to the n minus 1. So this thing right here is our r, and that's our u1. That's our first term, and that's our r. If I want to find the infinite sum here, right? If I want to find our infinite sum, it is u1 over 1 minus r, but I have to make sure that r is less than 1. My r in this case is negative 2/5. Again, don't care about the sign at all. That is less than 1. The actual value is less than 1. So I could find the infinite sum. All I gotta do is substitute it in. So we're gonna get u1, which is 6, over 1 minus negative 2/5. Again, if you want, feel free to put it into your calculator. I'm gonna do it by hand because I like doing math. Common denominator, So I get 6 over 7/5. Again, that looks scary, but it's just 6 divided by 7/5, also known as 6 times the reciprocal. So I get 30 over 7. Okay, next one. When dropped, a ball takes 1 second to hit the ground. It then takes 90% of its time to rebound to its newest height, and it continues until the ball is at rest. Show the total time of motion is given by this. 1 plus 2 plus 2. So it takes 1 second to go down. Then it takes 90% of that to go back up. So it's be like 0.9 times 1, so 0.9, and then back down again, 0.9. Then 90% of that to go back up again. So it's be like, what, 0.9 times 0.9? Also known as 0.9 squared. That's where you start seeing that come in, right? So it's in double it. So that's how I would show it. It's like that. It'll go on forever. Find Sn, the sum of the series. Now, it says Sn. So we want the formula for Sn. So this is a geometric series because we're multiplying by 0.9 each time, right? It takes 9% of the time. That's our R. For multiplying each term, then it's a geometric series. So how do we write a geometric series? It's the first term times R times n minus 1. What's our first term? 1. What's our R? 90%, so 0.9. So our Sn is 1 times 0.9 to the n minus 1. Like that. How long does it take the ball to come to rest? Now here's the tricky part of that. Right? You have to understand that it's going to go on forever. So this right here is an infinite sum. So how long does it take to go rest? We're going to come on bouncing forever. So it's an infinite sum. Now, could I find this infinite sum? Well, is R less than 1? It is. R is 0.9. So I could do the formula. U1 over 1 minus R. So that's going to be 1 over 1 minus 0.9. So that's going to be 1 minus 0.1. Also known as 1 over 1/10. So that's 1 divided by 1/10. Or 1 times the reciprocal. So 10. It's going to take 10 seconds to come to a complete stop. There we go. That's the lesson.